So thank you everyone for coming. I'm Mihai Maruseac from Google Open Source Security team, or in the words of Taylor Swift, it's me, hi, and I'm going to be the speaker now. Okay, so this is a talk about how do we secure AI, GenAI, but AI in general. So of course it's going to be a talk about AI. And if you know about AI, you also know that there is also the concept of machine learning. So I will use for this talk, I will use the terms AI and ML interchangeably, even though AI is a bigger field than ML, and actually GenAI is part of ML. But just for this talk, assume that they are the same, so just to clarify the confusion. And also we have traditional software, which is the term that I'm going to use for software that doesn't use AI. So basically all the software industry of the past several tens of years. And these two have differences, but also they have stuff in common. And the part that is stuff in common is also helping us secure the AI faster. So let's look at the common part. Both AI and traditional software have similarities, both in the way they have been developed. Both of them started as hobbies, as research projects. So AI started as research at Stanford and so on. Traditional software started as people tinkering with their computers at home, creating stuff and so on. After a while, both of them became commercials. You started having computers being released to big organizations to perform different computations and so on. You started having AI being deployed into smart devices. And after a while, they all become commodities. Everyone started having personal computers. Everyone now can start with ChatGPT and chat and do whatever applications that they want to do. Unfortunately, there is also a bad side that is also parallel. As the software or the AI become more and more prevalent, the number of attacks increases. So let's think of some of these attacks. The number one OWASP risk on a GenAI is prompt injection. And this is very similar to traditional software SQL injection. So both in terms of how it can be deployed and some way it can be protected in a similar way. Another risk in AI is data leakage. I censored the names, but we have the similar data leakage in traditional software. Every week, every other week, or sometimes multiple times a week, you hear about another data breach, and you get another settlement notice and so on, because your data has been leaked again by some hackers and so on. So we see it both in traditional software and in AI, it always exists. Another risk that is both in AI and in traditional software is malware. In this case, there is a research paper where you can hide malware in models, and then somebody later developed a GPT-4 model that has been trained on 4chan with malware inserted into it and so on. And then remote code execution. For models, for AI, because all the models need to be very powerful to do distributed inference, to run on GPUs, on TPUs, and so on. They have powerful operations incorporated into the language that you build the model. So for example, in TensorFlow, there is a special layer called the lambda layer that allows you to wrap a Python function. So now when you are executing that model, when you are running inferences of that model, that layer would execute a random Python function. The same way in Python, you can save a model as a pickle, and everyone knows that pickle is insecure. Pickle deserialization formats that can lead to remote code execution and so on. And for one more attack that is common in both fields, we have what we discovered with SolarWinds. We have attacks on the build platform itself. So I'm going to talk a little bit about this more. So because pickle has been discovered to be, because pickle is unsafe, safe tensors is a new format created for models to be able to load the model without having to do a pickle deserialization. However, the job that was converting a pickle model to a safe tensor model was running all of the jobs in parallel for all of the models on the same system. So as soon as you had one model with pickle that was able to drop some remote code execution on the build, all of the other models that would be converted to safe tensors would also have malware inserted into them because of the previous job. So it's very similar to the SolarWinds attack, where one compromise of the build system could then compromise all of the releases that would occur on that build system. Okay, why do we care? AI is being used for a lot of things. So it's being used to write code. It is being used to even build applications. You just chat with a specific ChatGPT application, and it builds the application in minutes. So you just describe, I want the screen that does this and that, and it builds the application for you. It's being used in smart homes, especially now that we are talking about AI agents that can look into your calendar, that can unlock your smart home, and so on. It's being used everywhere. It's also being used for fuzzing, as we saw in the keynote 2 days ago. And it's being also used to resolve dependencies, especially like SPAC, which is for high-performance computing. They use AI to determine which dependencies can result in a broken build, and they skip those directly to go to other ones. Okay, so let's now put the hat of a ML developer on and think how the model is developed. So as an ML developer, the first thing I have to do is pick a data set, an ML framework, and start looking at the data. So in this case, let's say I pick TensorFlow and I split a data set, CIFAR10, that has digit recognition. I split it into test and train data sets. That's part of the ML framework. Now I need to combine all of this together with some model source. So basically, this is the model that I want to train. And I combine everything to train the model. Once the model is trained, I put it somewhere into a model hub, so somewhere in storage, such that sometimes later, somebody will take this model and put it into an application, enhance the model to a production model, and put it into an application. And now I have the ML Power application that uses AI behind the scenes. Basically, users are not using the AI directly. They always use the AI via some application. Okay, if we look at this diagram, we can see that there are already some security risks. The ML developer can accidentally submit bad code for the model. Maybe some malicious mods accidentally leaves a Lambda layer inside the model. Or the ML framework could have vulnerabilities that are exploited. For example, parsing images, all the image parsers might have vulnerabilities. They can be exploited. The source control itself for the model can be exploited, or the training process can be exploited, or even once the model is trained, before it gets developed into an application, somebody could tamper with it in storage. And if we squint at this diagram, it is very similar to the salsa diagram. So it's the same supply chain diagram that we have seen before. Except for ML, it's a little bit more complicated because ML is not developed as a one-shot process. It's developed in cycles, especially for GenAI. So the bigger the model is, the more cycles you are doing. So let's start again from the data sets. I pick a data set from the internet, and instead of immediately putting it into the model to train, I run several data cleaning processes on it. I maybe combine that data set with another data set from the internet. I combine the sources. I might have missing information in the data set. I run some process to clean up that. So there is always a cycle at the beginning. Then once I have a model, I might not always start the model training from scratch. I might use an existing model and enhance it with more data. This is, for example, reinforcement learning with human feedback for GenAI, or fine-tuning. They are all formats of where I start from a model and then I create a new model based on it. A quantization of a model where I transform the weights from floating point to smaller to integers so that they can fit into mobile applications and so on. It's also another form where I train a new model from an existing model. So the diagram is still the similar supply chain diagram, but just with a little bit more loops around it. And the risks are the same everywhere. Okay, so now we can think about how we protect this. And I'm going to start from smaller levels that are a little bit more developed, and over the rest of the time, we're going to go over future ideas and so on. So the first thing that we can do is sign the model. As soon as the model gets trained, we sign it and we verify it either in storage or we verify it before we put it into an application and so on. This we can do with Sigstore. I'm going to have another talk on this after lunch in the other room. So this is what I'm going to say about this, except that signing the model, the way we sign the model, the way we hash the model, is going to also be at the basis for the rest of the supply chain protections that we are going to deploy. Okay, so let's move forward. The next step is to do salsa for models, where we can we can register information across the entire chain. Because ML training is not just a single step, we actually have to do a salsa statement for one loop on the dataset cleaning, another salsa statement for one loop of training a model, and so on. So it's not just one single salsa statement for one model, it's going to be a sequence of salsa statements. And we already have an example to run Salsa on GitHub, where we can train a model on GitHub Actions, smaller models, because we need to fit into some time constraints. And as part of that, this will also generate a Salsa provenance. And we can inspect the Salsa provenance. It will tell us exactly, because it's the GitHub generator, it will tell us, this one, it will tell us that it's a PyTorch model with a specific hash. And it will also tell us it's been generated by the Salsa framework and that from this repository, System Model Transparency at that commit. That's all that we have at the moment. We will need to add more information into the statement, so this is work in progress. Basically, what we need to do first is to make sure that we hash the model the same way we hash it for model signing. We also need to make sure that the Salsa statement is complete. So right now, as I showed in the examples, we only know that it came from this repository at this commit, but that's all that we know about the model. We want to include in the Salsa statement that this model has been trained from this data set or from this pre-trained model, maybe with this version of TensorFlow or whatever ML framework we're using, and so on. We also want to be able to generate Salsa provenances outside of GitHub Actions, because in general, people are not going to train their models on GitHub Actions. They're going to train them in Jupyter notebooks, in Colapse, in workflows that run on cloud environment, and so on. So we want to be able to generate Salsa provenance there. And in order to do that, we will need to basically create a certified ML trainer that is able to generate models in a secure way and generate a Salsa provenance there. And in order to do this, we should be able to integrate generating Salsa provenances first with Jupyter and Colapse, such that we can meet developers where they are. And maybe there is this concept of an ML package manager. Imagine in 10 years in the future when somebody wants to start training a model, they can do something like ML install this model, ML install this data set, and then train the process, and so on. And the package manager will be able to verify the integrity of whatever gets installed, will be able to verify the provenance for whatever you get installed, and so on. So that's the vision for Salsa for models. Okay, there are two other concepts that are very similar to Salsa in the ML world. One of them that comes from ML is the model card, which is more focused on the ML and aims to convey what datasets have been used to train the model, what licenses the model can be used, so in which scenarios you can use the model. Sometimes in a model card, you might see some graphs about the model performance. You will see information about how to cite the model, and so on. And then there is also the AI bomb, which is more focused on the final model, so the model that gets into production. And it flattens the entire dependency tree. So you'll have one AI bomb for the model that gets deployed into production. And you'll have this model has been trained on these data sets, on these specific models, and so on, depending on how complete the bomb is and how the standard will evolve. The AI bomb standard is still under development at the moment. So in the future, probably all of these free fields will be able, all of these three different statements will be able to cooperate together to get a better view on the supply chain for ML. But right now they are three separate directions and people are collaborating between them, and there are a lot of working groups that are mixing between themselves. Okay, let's look back at this diagram. As I was saying, there are a lot of cycles, both for data sets and also for training models. And in each cycle, we generate one Salsa statement or another provenance statement and so on. And we will need to understand the entirety of the supply chain when we are looking at an application. Let's look back at the traditional software. When we have a package from traditional software, it has a large number of dependencies. Each one of these dependencies also has a large number of dependencies and so on. So we have a big tree of dependencies, a wide tree of dependencies, but in general, the tree is narrow, is shallow. You only go like a few levels. And after that, you have the entire set of dependencies. Whereas in ML, because when you train a model, you start from a specific model and another data set, and then you fine tune, and then you fine tune this with another data set and so on. The tree is more narrow. You only have just a few set of direct dependencies, but it's very deep. You can go for GenAI, you can go multiple cycles over, you can train a GenAI model over a period of a few months. However, we can understand both of these graphs using, for example, Guac. This is something that we are starting to consider right now. I'm chatting with people from the Guac community to try to use Guac to understand the AI supply chain, to mix together multiple SALS attestations and multiple SBOM attestations about ML and try to understand the supply chain there. Okay, now let me put on an attacker hat. So suppose I'm an attacker and I want to exploit some users using ML. I have two models that I trained. One is an evil model that contains some malware, and the other one is the GPT-4chan that I mentioned at the beginning. And of course, I'm going to put these models to a model hub such that then users can download and put them into their own applications. Of course, if I just put the model there with clear descriptions that say, this is a bad model, don't use it, users are not going to use them. So I have to give them clearer descriptions in the model card. So I will say for the evil model that this is a malware detection model. It kind of detects it because it runs on your system and then you know you have malware. And for the other one, I'm going to say it's a friendly chatbot. It's a chatbot, friendly. Okay, users are still not going to use them because they see the names. They see, okay, this is an evil model. I'm not going to use it. I don't care about that. However, I can just change the names and upload the models, and users would not understand, would be none the wiser for this. And users cannot inspect the model to see if it's good or bad, if it behaves correctly or not, because the model weights are so huge, it's just a big list of numbers that are not interpretable. So the general idea is that by their own, the models are not attributable to the user that trained, to the person that trained them, to the identity that trained them. So what we can use there, what the community started thinking about, is maybe we can try to use S2C2F to create policies about how you should load models from datasets, from Hugging Face or from repositories, under which conditions you should, what you should consider before you start using models into your applications. And this will be like merging all of the attestations that we have about the models, model signatures, and so on. This is work in progress. We just discussed this Monday at the AI working group. So expect more stuff to come around this area soon. Okay, and then other items about ML and security that are still in the incipient phase are about dependencies between models. So imagine sometimes in the future you could go to deps.dev and you could see this model has been trained from this specific other model. So you could see like an ancestry of all of the models. And this way you can analyze, okay, this model has been detected to be bad or to contain some info, to be too old, to be too stale, and it needs to be retrained. You can see exactly what other models you need to retrain. Or for vulnerabilities in ML, maybe we can extend the VEX schema to also include vulnerabilities in ML. And the same for OSV, for vulnerability databases, we can extend that to include information about ML. This is all just at an idea stage. We can discuss more in the OpenSSF working group and so on to progress on this field. We have a supply chain white paper about the AI framework, about the AI, securing GenAI, which talks all the way until the guac. So everything that came after guac in these slides is new ideas that is not covered yet. But the general idea is that as AI gets being used more and more, we see the same traditional attacks also happening in the AI software. And we are also thinking that the traditional supply chain solutions can apply to AI. That will be like the conclusion of the summary of the white paper. And then to end, I will have 3 different QR codes. The first one is for the repository where we have model signing and salsa for models with GitHub Actions. The second one is the white paper that I mentioned just before. And the third one is the AI working group. If you are interested in security and AI, please join the working group or any other working group on AI. We are interested to get more efforts, more contributions from anyone, and so on. And thank you, everyone. I'll stop for questions.